Welcome to Spaceverse, your portal to cosmic adventures. Astronomers are peering deeper into the cosmos than ever before. And now, thanks to the James Webb Space Telescope, we're witnessing something truly extraordinary. A breathtaking new image has revealed the complex, chaotic final chapter in a star's life. And it's not just beautiful, it's rewriting what we thought we knew about planetary nebulae and binary star systems. This is a journey into the heart of a cosmic wonder, and an opportunity to unravel the mystery behind a dying star's last breath. Above the Earth, in the constellation Taurus, about 1,500 light-years away, lies NGC 1514, a planetary nebula glowing against the darkness of space. Despite the name, planetary nebulae have nothing to do with planets. The term comes from an old telescope observation that made these objects look vaguely like distant gas giants. But in reality, what we're looking at is the spectacular death of a sun-like star. This glowing structure is formed when a star expels its outer layers of gas and dust into space, leaving behind only its core. And in the case of NGC 1514, there's more than meets the eye. At its center, two stars orbit each other in a complex gravitational dance. But even through powerful telescopes, they appear as a single point of light. Only with the unmatched power of the James Webb Space Telescope could we finally peer into the core and see what's really going on. Using the telescope's mid-infrared instrument, MIRI, scientists revealed something astonishing: two clumpy, overlapping rings of dust shaped like a Venn diagram and surrounding the central stars. These aren't just beautiful. They're vital to understanding how stars die. Mike Ressler, a project scientist for MIRI who originally noticed the rings back in 2010 with a different NASA telescope, said, "We couldn't even detect most of this material before Webb, much less see it so clearly. Now, for the first time, astronomers can analyze the long-term outflows of stellar material with incredible precision." Earlier research showed that the two stars in NGC 1514 orbit each other every 9 years, one of the longest orbits ever observed for a planetary nebula's central system. The larger star is believed to be responsible for creating the nebula in the first place. As it aged, it expanded rapidly, shedding layers of gas and dust through stellar winds, before collapsing into a white dwarf, a hot, compact remnant of its former self. This dying star expelled its outer shells into space. But the story doesn't end there. Planetary nebulae like NGC 1514 are more than just cosmic remnants, they're galactic recyclers. When stars like our Sun die, they don't explode in violent supernovae. Instead, they gently release their enriched elements into space, creating beautiful glowing shells. Over time, these elements, carbon, nitrogen, oxygen, are incorporated into new stars, planets, and even the building blocks of life. Without planetary nebulae, the universe wouldn't have the ingredients for complex chemistry. But the exact process behind their shapes and structure has remained a mystery. Why do some nebulae form perfect spheres, while others create twisted shapes, lobes, or in this case, double rings? The answer lies in the interaction between binary stars, magnetic fields, and time. That's where Webb's sharp infrared eyes become essential. They allow scientists to cut through the surrounding dust and decode how these forms emerge layer by layer over thousands of years. The faster, lighter winds from the white dwarf push through the earlier, slower-moving material, creating clumpy, layered rings of dust and gas. Near the core, there's something even more dramatic, a web of holes and channels where fast-moving matter blasted through the slower outer layers. Webb captured it all. This level of detail was impossible before. As the dying star lost mass, its binary companion may have passed incredibly close, influencing the material in ways that shape the nebula's structure. Instead of a symmetrical shell, this interaction may have created the twin rings now observed. David Jones, a senior scientist at the Institute of Astrophysics in the Canary Islands, helped confirm the binary system in 2017. He explained, "The companion star could have come exceptionally close when this star was at its peak of losing material. That interaction can lead to shapes you wouldn't expect. Instead of producing a sphere, this interaction might have formed these rings. The rings appear clumpy, uneven, and softly lit, made up of tiny grains of dust, each warmed ever so slightly by the ultraviolet radiation of the white dwarf at the core. These dust grains are so fine that they only absorb small amounts of energy. But that small amount is enough. When hit by UV light, they heat up just enough to be visible in mid-infrared light, precisely the range that Webb was designed to observe. And the surprises don't stop there. In the nebula's pinkish core, oxygen was found in abundance, but other expected molecules were missing. Carbon and polycyclic aromatic hydrocarbons, molecules that are commonly seen in other planetary nebulae, were nowhere to be found. This absence raises new questions. Why are the usual chemical compounds missing? What's different about NGC 1514? One theory points to the long orbital period of the binary stars. Because their orbit takes 9 years, the interaction between them happens less frequently. That might limit the complex chemical reactions needed to form these compounds. So we're not just learning about structure. We're learning about chemistry and how a star's death affects everything around it. All of this, made possible by one telescope. The James Webb Space Telescope is the most powerful and advanced observatory ever launched into space. At a cost of $10 billion, it's the crown jewel of astronomical research designed to detect the faintest, most distant light in the universe. Its infrared capabilities allow it to see through thick dust clouds, detect complex molecules, and observe the birth and death of stars. And because of that, it's in extremely high demand. In fact, astronomers have already submitted enough research proposals to fill 9 years of telescope time. But now, while the telescope is only halfway through its primary mission, it's facing a major challenge. Budget reductions are being considered, reductions that could affect every part of the mission. At the annual meeting of the American Astronomical Society in January, Tom Brown, who oversees Webb's mission office at the Space Telescope Science Institute in Maryland, explained the dilemma. Frankly, he said, this mission works far better than most folks expected, and it's extremely worrisome that, while we're in the middle of the prime mission, we're also maybe looking at significant budget reductions. If these reductions go into effect, they'll slow down critical tasks like reviewing new proposals, analyzing data, solving unexpected issues, and supporting the global research community. All this while Webb is delivering the clearest images and most detailed observations we've ever seen. It's a frustrating situation, but also a powerful reminder. Great science doesn't just need brilliant tools. It needs long-term commitment and support. And in return, it gives us the universe. So what are we really seeing in NGC 1514? We're witnessing the last breath of a dying star, a moment frozen in time, a structure sculpted by gravity, pressure, heat, and motion. We're watching gas and dust collide. We're seeing light travel 1,500 years to reach us. And with the help of Webb, we're not just observing that journey. We're understanding it. Stars live. Stars die. And in death, they leave behind beauty and mystery. Thanks to modern astronomy, we get to witness that process firsthand. The cosmos is filled with wonders, and this is just one. Thanks for exploring the universe with us. This is Spaceverse, where curiosity has no bounds and every star tells a story. If you enjoyed this journey, don't forget to like, subscribe, and ring the bell so you never miss another trip through space and time.